60, 59, 58, 57, 56, 55, 54, 53, 52, 51, 50, 49, 48, 47, 46, 45, 44, 43, 42, 41, 40, 39, 38, 37, 36, 35, 34, 33, 32, 31, 30, 29, 28, 27, 26, 25, 24, 23, 22, 21, 20, 19, 18, 17, 16, 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
Hello everyone, welcome to my first live stream as a YouTuber, and this is a very important launch. This is the James Webb Space Telescope, and this launch is going to be done in the region of French Guiana, which is in South America, but it is a territory of France. So from there we're going to get this fantastic rocket, which is going to be lifting off, and it'll be going to a point known as Lagrange 1.2, which I'll be introducing you to in a few minutes. So are you excited, guys? This is a very exciting mission when you look into the 5-10 year time frame. It is a very important mission because the Hubble Space Telescope has been working for 30 years. And now, I guess in 1 or 2 years, it's going to be retiring, and it'll continue to start losing altitude and finally falling into the Earth atmosphere. So this is a very important mission. One of the most important missions in 2021, but it's occurring in the last. So in the beginning, I would like to introduce you to the trailer to the mission, and that's going to be in a few minutes.
We have uncovered wonders undreamt by our ancestors who first speculated on the nature of those wandering lights in the night sky. We've crossed the solar system and sent ships to the stars. But we continue to search. We can't help it. A central element of the human future lies far beyond the Earth. If we crave some cosmic purpose, then let us find ourselves a worthy goal.
Futuristic, a very goosebumpy kind of beginning to the trailer, and it has been quite a good one. Again, very excited to start this mission, and so hello Mike 5890. I'm also very excited. I'm also very excited that you are excited. We have got 2 viewers, I guess, right now, or 3. But yes, I'm really excited. We'll be starting in a few minutes. There's still, I guess, around 30 minutes to the launch. It's around 5:50 p.m. So it's going to be a very exciting one. Let's start it. Um, so, just a second. Okay. So, first of all, I would like to introduce you to the rocket launch. What is the mission? What is the mission for? What is the James Webb Space Telescope? This is all what I'm going to be explaining. So let's start with Hello JWST. Okay, so before I begin, okay, let me just introduce you to my presentation I've just created. Yes, perfect. So this is the presentation I've made for the James Webb Telescope, and it's very interesting. It is actually being launched 5 years late. I'm pretty sure it could have been launched in 2016, 2017, but it's being launched around in 2021. If there were a few more delays, it would have gone as far as 22, but I'm really excited for this beginning. So 5 years late. So what is the mission, first of all? So the primary goals are to observe the first light of the Big Bang. If you've watched my second video on the space thing, on the space video, the second one was the theories of the universe, and there was the Big Bang theory. So that is, expansion of the universe from a single multi-dense point. So, the Big Bang is nothing but that point. And if you have seen the video, you really know what I'm meaning, right? The first light actually, it starts from being gamma, and then it starts losing its information. It starts to have a longer wavelength. The wave will start to become a bit more relaxed from being compressed, and by the time it reaches us, it'll be in the infrared radiation point. It's going to be above the um, visible light, so it's not going to be visible to our eyes. But then if you view the universe by the infrared radiation, you will see much, much more than that. So this is what it is. First light after the Big Bang, to observe how do galaxies form. Because again, we're going to get light. We're going to be looking into the past. Typically, we are going to be looking into the past. So this is how it is, right? Galaxies form. We can see the galaxy formation. Similarly, planetary formation and search for life. That is a um, you know not as a primary goal, but as a search for hypothetical questions. This is a very hypothetical question. Primary lifespan is about 5 years, and it's expected to live about 10 years. We don't know till now. We have to wait for a few more months, or maybe 1 or 2 years, to get to know what's going to happen. And for comparison, Hubble was actually with a small lifespan, like this only, 5 to 10 years, but then it managed to live about 30 years. 30 years. Uh, One of the cause is that Hubble is very close to the Earth. It has been repaired by many space shuttle missions. There have been many space shuttle missions which have gone for the repairing of this mission, of this Hubble Space Telescope. So, due to that, the lifespan has increased, and it is expected to start from May to June 2022. Location is L2 point, Lagrange point 2. I'll be explaining that in a few minutes. OTE means the optical telescope. It's here, optical telescope element, right? So this one is going to be diameter, right? As you can see, this golden area, the diameter of this golden area is nothing but 6.4 meters, whereas for Hubble it is 2.4 meters. What is the difference? Now if you have a larger optical telescope element diameter, this nothing but means that you're going to have more light which is going to come, more light is going to reflect onto your surface, and you're going to collect eventually more light, which will help you in getting to know. And this doesn't mean that Hubble did not observe IR, infrared radiation. It did, but then it was very short. Now this has a complete this telescope can now completely view IR, doesn't matter whether it is short or long range. Then the viral journey, as I would like to say, this is the roadmap for when it started and where it is till now. So the plan for this telescope initially started in 1996 when Hubble was in space, and initially in the first few weeks only we got information that there is a problem on the telescope. So due to that, there were many missions going up. So that was a problem, right? So that's why we had another mission which was put in, and this one was going to be even grander. This was going to be even more important than the Hubble. But Hubble is just a workhorse, still working since for 30 years, and that's really a very amazing thing. Okay, just a second. Yeah, so one second. Yeah, so in 2002, this NGST, Next Gen Telescope, Space Telescope, NGST was renamed in 2002 to James Webb Space Telescope. And the construction started to begin in 2012. Um, the fabrication process started. Till then it was all the hypothetical, which points would go where, the instruments would go where, and the more or less designing of the mission. And construction began in 2012. Before going ahead, I would like to thank Deepti Malhotra for supporting us, and thanks for watching this stream. I would like to thank you, and many of the comments which are coming up, I'm really grateful for the comments. So let's just continue. So the construction began in 2012, and the construction got completed by November of 2018. This is also because, again, there were many problems. One incident was that a piece, I guess during the cryogenic test, one of the piece just broke off. It tore, and due to that, they had to do a serious check of what is happening. What happened? It's, I guess, 2016. That's around 20, around, yeah. So what they had to do was that they had to check, and they found that there were around 360 points, 360 points in the entire telescope, which could be cause of a failure. 360 points of a failure. That's really bad. But it's now delayed till now. The launch was delayed due to COVID-19. There was a hurricane which occurred, and due to that, it has been delayed, and it's still today. Today, the weather at Kuru, one second, just before we move on forward, we'll just continue and complete this. So the instruments in JWST, which are installed, we have the science instrument module, which holds all the science instruments and the cameras. The trim flap maintains the stabilization. Trim and flap. Most of you guys who are in aviation, who aspire for aviation, but no trim and flaps, the up and the yaw and roll. So this is nothing but the stabilization of the telescope. Then we have the solar panel array, which is converting the solar energy to electricity. Earth pointing array always points towards the Earth, beams information to NASA space centers. We got the star trackers, that is nothing but the gyroscope, and the one which initially shows if you're in the perfect position for doing. 5-layer shield, which is this, as you can see, the sunshade. This is for protection of this ISIM, which is here, and you've got the primary and the secondary mirror, which I'll be explaining in a few minutes. Then we have got the primary mirror, which is made up of beryllium and coated with gold, captures faint infrared light. Beryllium, well, I also don't know, but yeah, it's made of that, and it's coated with 1,000 atom thick gold. It's very, very thin, right? And then we've got the spacecraft bus, which is nothing but the brain of the spacecraft and makes most of the decisions regarding the orientation and angle of the primary mirror. Fine. And this is, movable. Then we have the OTE. As you can see, there are 16, if you count it, there are 16 hexagonal plates, gold plates, and, primarily also made of beryllium. So the instruments installed in the optical telescope element, OTE, of the James Webb Space Telescope include the 16 hexagonal plate primary mirror, and you've got a secondary mirror which stores the light and sends it to the ISIM, that is the the instruments. Now let's just see the 3D model. Just a second. So we've got the 3D model. One second. Right. So share screen. One second. Yeah. So right, as you can see, um, we've got the James Webb Telescope in 3D model, as you can see here, right? So as you can see, there are 16 hexagonal plates here, and we have also got the secondary mirror here. We have got the beaming object, it beams the light which is reflected. It goes exact at this point and again goes into this. Got the science instruments kept here. This is the trim flap, and it also has solar panels for electricity. And then we have got the electricity making. We have got three main powerhouses for electricity. With the bus, spacecraft bus, the brain of the telescope, which is for the stabilization and all that purposes. As you can see, one second. As you can see, there are 5 layers of sunshade. Right? These are the sunshades, as you can see, and this is the entire telescope as it is. So yeah, here, and we have got the antenna, which, oh sorry, right, as you can see here, we have got the antenna which beams the information from the telescope to the Earth space centers. Right, fine, just a second. Okay, so we have finished viewing the space telescope. We have also seen the space telescope. We have also got to know more information about it. And just a few minutes, and I'll give you another website. Yeah, here. So let me just share. Okay. Yes. So this is the James Webb Space Telescope, as you can see, right? This is all what I explained using the 3D model, right? So this is the James Webb Space Telescope. You'll be seeing it in real life, which is being launched to space. Fine. So I would like to thank Everyday Astronaut for supplying the information for this live stream. And this is a very important, if I would say, information. So if you say liftoff time, this is around December 25th, which is today, at 12:20 EOTC, which is around 5:50 p.m. It's still around 12 minutes left, so I'll just explain everything. Then we've got the mission name, which is the JWST, James Webb Space Telescope. Launch provider is Ariane Space, that is nothing but the ESA, a subdivision of the ESA, that's the European Space Agency. Customer is mainly NASA with the ESA, as I said, and Canada Space Agency with other institutes. And the rocket which is going to be used is the Ariane 5 ECA. Now, what is ECA standing for? I'll just be explaining. So, ECA is nothing but, again, get this, and we've got the ECA. Information on the ECA. So, it is a European heavy lift launch vehicle which is developed by Ariane Space for the European Space Agency. It is regarded as one of the most reliable rocket vehicles on Earth, and it has launched 109 times with a 95.4% success rate. So if it is launching today, it has 95% of chance that it would succeed in putting the telescope. And I guess it has to, because this is 30 years, $10 billion at stake. From the Ariane 5 launches from the European spaceport in French Guiana, in Kourou, which is, I guess, the capital of that area. And this is a spaceport which is the closest to the equator which you could get. A rotation speed there, and it boosts the launch performance, because there's the maximum rotation speed on Earth. The ECA version is nothing but it is launching two large satellites, because the normal Ariane 5 would not be able to launch JWST even if it is crouched and being launched. That's why it is ECA. And here you have an adapter called SILDA, and the adapter covers the lower satellite and supports the higher satellite. So this means when it's in space, when you remove the fairing, that's the cone, as you can see here, this cone. So when it happens, that time we are going to be getting um, the upper satellite is going to be coming out, and then the cylinder will get ejected, and then the lower satellite will come out. So JWST cannot be fit into any launch vehicle when fully expanded, so it has been folded, and it will be unfolding segment to segment over the 2 week period as it makes to the final destination. But it'll start its works 6 months later, May to June 2022. It will be unfolding during these 2 weeks, but once it reaches there, then only it can calibrate its location, and start to support, start to get the position from where it needs to, start working, right? So this is the Ariane 5. This is the James Webb Space Telescope debusted, completely explained, and we'll move on with the launch. Okay, we have got 9 minutes to go. So just a second. Okay. So before I move on forward, if you are on Discord, then I've got my link in the description below, also in the comments and the live chat, as you can see on the screen, I guess. Yeah. So the link is in the description as well as here. This is going to work only for 7 days, so hurry up and join my Discord server if you are on Discord. So let's continue. Fine. So we have done the first, and we have done the second thing. Now it's time to move on with launch time. So we'll start in a few minutes. Let me just calibrate in with our website. Okay, just a second. Okay, fine. Just a second. Okay, so as you can see, there are 7 minutes
He will be
left.
calling the start of synchronized sequence, all of the critical countdown milestones, and we will be listening very intently for his calls. Let's stand by.
À tous de DDO. Attention pour la séquence finale lanceur.
So he's speaking in French.
Top. À 0 moins 7 minutes.
And with that, we've entered the period of synchronized sequence. You heard Luce Fabriquet just a moment or two ago explain some of the critical activities. The first one coming up just a few seconds from now, which will be the topping off of the main stage tanks. The first or core stage was loaded earlier this morning with 175 tons of propellant, 150 tons of liquid oxygen, and 25 tons of liquid hydrogen. The upper stage loaded with 15 tons of propellant that will be the workhorse for a 16-minute burn to lift James Webb to its final orbit. At separation, some 27 minutes and 7 seconds after launch, James Webb will be at an altitude of about 864 statute miles. To put that into perspective, some 520 miles higher than the Hubble Space Telescope and more than 600 miles higher than the International Space Station. Webb at that point will be traveling about 21,000 miles an hour as it heads out to a highly elliptical halo-like racetrack orbit some 1 million miles from Earth to begin its scientific observations.
in a little more than 1 minute from now, we will see the 4 tanks pressurized at their flight level for the last tests before the ignition of the Vulcan engine. And in parallel, the electric system are also set in flight configuration. The onboard computer, the electrical power, as for the telescope, it will switch from ground to internal power 1 minute before the launch, 1 minute and 5 seconds before the launch. And we are going to see -6 seconds. At -6 seconds, we will see the disconnection of the upper stage, these big cryotechnic arms you can see on this picture. Then 3 seconds before the H0, the inertial platform that will give all the information about where it is to the launcher will be released. And at H0, the 7-second sequence to ignite the Vulcan engine of the main stage will start. That will take 7 seconds, a little less than 7 seconds, where the engine will start up to its flight regime. Once the computer has checked that the Vulcan engine is running normally, and you will see at that point a flame going stable at the outlet of the nozzle. And at that point, the onboard computer will ignite the 2 boosters that will enable to move the 770 tons of Ariane and Webb.
Coming up on the T-4 minute mark right now, just a couple of milestones real quick. At the 1 minute 5 second mark into the flight, Ariane 5 will go through the period of maximum dynamic pressure, max Q as it's known. That will be the period of maximum aerodynamic forces on the rocket itself. The solid rocket boosters, which will provide about 90% of the initial thrust off the launch pad, will shut down and separate at the 2 minute 21 second mark into the flight, followed 1 minute and 5 seconds after that by fairing jettison. That will expose the James Webb Space Telescope to the environment of flight for the first time. The main stage separation, or the first stage separation, comes at the at the 8 minute 47 second mark into the flight, and that will be about a 16-minute burn of that upper stage engine. It will cut off at about 24 minutes 51 seconds into the flight, and then we'll go into a coast phase of about 2.5 minutes to allow any oscillations to dampen out, provide the most pristine environment for the James Webb Telescope before observatory separation. We're coming up on the 2 minute 50 second mark into the flight. Again, you're going to be hearing critical calls down the stretch here from the DDO, or the Range Operations Manager, Jean-Luc Voyer. The weather is go. We have a green board, no issues being worked. NASA officials, including Greg Robinson on the right, carefully watching the telemetry, looking intently at the final couple of minutes of the countdown. Lives have been spent in the preparation of the James Webb Space Telescope that is about to fly.
And Beatrice Romero on his side, on the left of
The
the screen,
weather at
from
Kourou
Ariane
is
Space.
around 27 degrees Celsius, and the precipitation
And that is the
around
DDO, the Range
66%.
Operations Manager, Jean-Luc Voyer, as we have hit the 2 minute mark in the countdown.
Yeah. 2 minutes. Let's go, Ariane Space. Let's go, NASA. And let's go, James Webb Space Telescope. Let's do it. So as you can see,
The flight will
important
be in 2 phases.
dignitaries
You will
are
see the
going
first part of
towards
the
launch
flight
site and
during the solid rocket boosters phase. That will be the atmospheric part of the flight, the atmospheric flight, and the trajectory will be driven by a to reduce the aerodynamic loads, and we will have a very different exo-atmospheric flight after that.
And you were watching a number of people, VIPs and invited guests, moving out to the observation platform that is right next to the Jupiter Control Center, as we stand by for the 1 minute call from Jean-Luc Voyer.
À tous les DDO, attention pour moins 1 minute. Top, à 0 moins 1 minute.
Thumbs up from Jean-Luc Voyer. All systems are go. We're inside a minute now, T-minus 50 seconds and counting. As you heard earlier, the Vulcan 2 engine will ignite. Turbo pumps will come up to flight speed for 7 seconds, and the command will be issued to ignite the solid rocket boosters. The James Webb Space Telescope will be on its way.
Okay, so how's the stream going? In the comment section below. We have reached the 30
T-minus
minute
30
mark.
seconds and counting.
Okay, T-minus 30. Very excited. So as you can see, that's the point
Standing
where
by
the
for terminal count.
satellite is.
À tous de DDO, attention pour les décomptes finales. 10, 9, 8, 7, 6, 5, 4, 3, 2, unité.
Ignition. Yes, we have got ignition.
And we have engine start.
And engine start. Liftoff.
And liftoff.
Liftoff of the
Decollage,
Ariane
liftoff from a
5
tropical
ECA.
rainforest to the edge
What a
of time
beautiful start
itself.
is it?
James Webb begins
To
a
the
voyage
life
back to the birth of the universe.
Satellite. Wow, it's looking beautiful.
Punching a hole through the clouds, 20 seconds into the flight. Good pitch program reported.
Just beautiful. So, as I would like to add,
Trajectoire
what
nominale.
is liftoff? So, it is a stage when the
Vehicle
rocket
performance
engines
is nominal.
become active and expels out gases at a high pressure and temperature, which causes thrust to be
The
called,
Ariane
as you know,
5 rocket
it
continues
is F is equal to
to
MA.
fly uphill in nominal fashion.
And then we've got ascent. Now, what is ascent? Ascent is
The
a stage
rumble of the powerful Ariane 5 now being
when the
felt here in the
rocket
control
engine
center.
gains enough speed. As you can see,
3D
it's like
animation.
Kerbal. It looks Kerbal space.
We can hear the noise and
Nice.
feel the
But
vibrations here.
it is
You're
a
right,
stage
Rob.
when the
Yeah.
rocket gains enough
Impressive.
speed and thrust
13
to go
kilometers
higher
in
the air. As
altitude,
you can
7
see, the
kilometers
rocket is
downrange,
doing that perfectly and
traveling
increasing altitude.
about
Let me just explain
0.6
what's going
kilometers
on
per
there.
second.
What's
Tous les
this
paramètres à bord sont normaux.
chart which they're showing? So
The
initially,
trajectory reported to be nominal
this is
by
talking
Jean-Luc
about
Voyer,
the
the
altitude
range
to the
operations manager.
distance
You can
has
see at the
been
bottom of your screen, the
has
yellow
been
line is
gained.
the
So as you
trajectory
can see,
plot,
we have also
perfectly
got
overlaid
around
over the green line, which was the pre-launch
30
trajectory.
kilometers height.
1 minute,
And then we have
41
got
seconds into the flight,
around
about 40
30%
seconds away from
Pilotage est calme.
shutdown of the solid rocket
As you
boosters.
can see, it's going like this. It's really exciting.
Coming up on the 2-minute mark into the flight.
2 minutes.
When it detects the threshold on acceleration, not the deceleration, but less acceleration for
Tous les
the,
paramètres à bord sont normaux.
everything is okay, everything is normal.
2 minutes, 15 seconds into the flight.
When the computer detects this threshold, it will separate.
Séparation des EAP.
Done.
We have confirmation of solid rocket booster separation from Jean-Luc Voyer. This coming at an altitude of 44 miles. The Ariane 5 and James Webb traveling almost 5,000 miles an hour.
5,000 miles.
We have about 1 minute, 5
This is
seconds to
around
go before
70
fairing
kilometers,
jettison.
right?
That'll be the next critical milestone.
The fairing is there to avoid the satellite being exposed to high temperatures and also high airflows. And as soon as the launcher leaves the atmosphere, as is now the case, the satellite does not need anymore to be protected, and Webb does not need anymore to be
Les paramètres à bord
protected.
sont normaux.
So
As you
each
can
kilogram
see,
being very
two
important
side
for the
boosters
performance of
have
the launch,
separated,
we are going to
and we are
eject
getting
this
just the
no
main
more
booster,
useful
which is
fairing.
propelling it to the space. So as you can see, distance from 195
And let's go down to the floor in the Jupiter
200
Control Center
kilometers
to Raphael
above
Chevrier of
the
Ariane
Earth,
Space. Raphael, so
right?
far so good.
So the speed is
Hi, Rob.
around
So far, so good.
2.3.
Everything is
Oh, there
nominal.
it is.
As,
There it is.
we say when
Separation. We can
attitude
see
and
the James
trajectory
Webb
of
Space
the Ariane 5
Telescope
is going
as
perfectly well.
in
As you can see also
animation.
on the
Wow,
yellow
that's
Lagrange de la
beautiful.
coiffe.
on the screen, we had the confirmation of the separation of the two solid boosters and now of the fairing, meaning that we have crossed the limits of the atmosphere. So everything is
Tous
going
les paramètres à
super
bord sont
good.
normaux.
And the DDO just said that all parameters
Okay, as you
are
can see, this
going
is the camera. You
perfectly
can see the
smoothly.
James Webb
So
Space
let's continue the mission.
Beautiful.
And Raphael, this is a view from the upper stage camera called the Vicky Cam. Looking back at the James Webb Space Telescope, this is on about a 20-second delay or so because of the way the imagery is processed here in the control room. There's your telescope ready to unfurl its wings, basically, and begin its journey to the Lagrange point, the L2 point, about 1 million miles away from Earth.
The stage of the rocket stops working, zeroing the acceleration for a few seconds. Now
Trajectory is nominal. The report from Jean-Luc Voyer. The liftoff time confirmed here in the Mission Control Center at 12:20 Greenwich Mean Time, 9:20 a.m. Peru time, 7:20 a.m. Eastern Time. The Ariane 5 and James Webb, 181 kilometers in altitude, 450 kilometers downrange from the launch site here in Peru.
So altitude and distance is quite different, right? Distance is nothing but the horizontal distance from
5 minutes, 12 seconds into the flight.
In flight to
we have about 3.5 minutes to go in main stage or first stage performance. And again, you can see at the bottom of your screen the yellow plot line overlaid over the green line, meaning we are right on course, right down the pike, and a perfect trajectory so far for the Ariane 5 rocket.
Okay. You're going to get a separation in a few seconds, I'm pretty sure.
All telemetry data are now received by the Galileo tracking station, which is close to here, where we are in Kourou. It will track the launcher and the ignition of its upper stage, and then we'll have the natal station in Brazil, Ascension in as you can see on the map, in the middle of the ocean, and the two last stations in Africa, Libreville and Malindi, one on the east coast, the other one on the west coast. And the one on the west coast, Malindi, you can see that the satellite the telescope will be separated more or less over this Malindi station. And this Malindi station will also acquire the telemetry data from the telescope. You can see both are green, Galileo and Natal on this animation. It means they are expected to receive the data, and it was confirmed right now by the launch operations manager.
Acquisition de la télémesure par la station du Natal au Brésil.
And just confirming now that telemetry is being processed through the Brazilian tracking station. The telescope is also processing telemetry through the tracking and data relay satellite system. As it moves further and further out into deep space, all of the telescope's telemetry and its imagery ultimately will be processed through the Deep Space Network in Goldstone, California. We passed the 7-minute mark into the flight. A perfect ride so far on the Ariane 5. We have about 1.5 minutes to go in the first stage performance. Once the main stage engine is commanded to cut off, it will be jettisoned. And just a few seconds after that, the upper stage engine will ignite, and it will be the workhorse for a 16-minute burn that will put James Webb into its preliminary orbit. About 11 minutes from now, telescope controllers at the Space Telescope Science Institute will be sending commands to prepare James Webb for the initial series of commissioning activities that will lead to the deployment of its solar array and the initiation of generation of electrical power for the telescope. About 30 seconds away from main engine cutoff.
Okay. So as I was going to tell this. Main engine cutoff. Okay. So
La trajectoire est normale.
So it is a stage.
Nominal trajectory continues to be the watchword for the day from the range operations manager, Jean-Luc Voyer.
Stops,
as we stand by for main engine shutdown and separation.
Has been zeroed for a few seconds, just a few seconds. And yeah, now you can see the main engine cutoff is done. You're going to get separation in a few seconds. Done. That's
Extinction de l'EPC.
What is separation? So separation is a
Opération EPC.
stage when the rocket stops
And we have main
accelerating
stage
and it
shut
breaks
down
into
and
two, one
separation
heading to
confirmed
space,
here in the Mission
one
Control
heading to
Center,
Earth,
and the
that's gonna be
ignition of that
paired.
upper
Allumage
stage
ESC.
So as
at
you can see,
Raphael
this is the
Chevrier
second
down
stage.
in
I
the
guess this
fishbowl.
is the
So far, so good.
Yes, Rob, we have the confirmation of the separation of the main stage
forgot to
and the
use the
ignition of the
trajectoire
upper
est nominale.
stage.
You know?
The trajectory is perfectly nominal. This is very important moment for us because it's always a challenge to switch on a cryogenic engine in space condition, and we are now at 220 kilometers of altitude. Speed is a bit more than 7 kilometers per second. As we enter now the second stage of the second phase of the flight, the upper stage is going to power for
Pilotage est calme.
about 16 minutes to place Webb on its transfer orbit, and right now everything is again nominal, as the DDO just said.
And a short time from now, the so-called sawtooth maneuver will get underway. Again, like rocking a baby in a cradle, this will be a maneuver to keep Webb's optics protected from overheating, Luce.
Exactly, Rob. Like baby in a cradle. You can see here Webb attached on top of Ariane 5 upper stage with a very specific configuration. Of course, it will be different during its lifetime, but for the time being, its sun shield is folded and not yet fully protecting the observatory. A number of exhaustive studies have been performed by the mission teams in Europe, in the US, on the thermal conditioning inside the telescope and the way the rays of the sun would propagate and interact with sensitive equipment inside the telescope. Maintain this thermal conditioning is really key before separating this telescope. And in particular, we know that one face of the telescope cannot face the sun. That's why and to produce these right thermal conditions inside Webb, a specific roll law has been designed, what we call the sawtooth approach. And if you are watching carefully to these images, you can see on this animation, you can see that the upper stage is going 30 degrees on one side, then 30 degrees on the other side, going back and forth this way to maintain this perfect thermal conditioning for the telescope.
It's worthwhile noting that after Webb separates from the upper stage of the Ariane 5 rocket, which continues to perform in excellent fashion, coming up on the 12-minute mark into the flight, the telescope controllers will be taking the baton, if you will, from the mission controllers here in Kourou. The first steps will be the opening of fuel valves, a pair of fuel valves, to start flowing fuel to Webb's onboard thrusters. They then will power on the valve drive electronics. Those are powered on in preparation to control and fire those thrusters when required. Webb's solar array is scheduled to be deployed at approximately the 33-minute mark into the flight. Once it is locked in place, we'll get the call that electricity is flowing through the array. That call will come from the mission operations manager, Carl Starr, who's at the Space Telescope Science Institute at Johns Hopkins in Baltimore. Seated right behind him in that control room is Alicia Starr, a pair of stars helping to guide James Webb on its discovery of the stars. Alicia Starr is the lead engineer for launch and ascent events. Once the solar array is deployed and declared power positive, then 3 out of the 4 hold downs for the aft deployed radiator will be released to prevent binding due to the cool down of the telescope's composite structure. The contamination control heaters will be enabled to protect instrument optics on Webb from any water ice condensation as they cool down. The actuator drive unit will be powered on. This particular mechanism helps with heater control of the fine steering mirror, preventing water ice condensation, later to be used to position each of the mirror's segments. All 6 reaction wheels and the wheel drive electronics will be powered on for Webb, and that will be the precursor to the attitude control system using those reaction wheels to maintain the proper orientation with the sun, as opposed to using onboard thrusters. Of course, fuel in those thrusters, very valuable. It's a limited commodity for the lifetime of James Webb's observations of the universe. We're 13 minutes, 55 seconds
Puis les
into
paramètres
the
à bord
flight.
sont normaux.
Jean-Luc Voyer, the range operations manager, continues to report a nominal performance for James Webb. And again, Luce Fabriget from the European Space Agency, how is this trajectory being carefully and methodically adjusted to provide the correct parameters in the final stages of ascent?
Yes, Rob, as you can see on this plot, the altitude is slightly going down. It's perfectly normal. The launch vehicle is really on the line where it should be. This decrease of its altitude, slight decrease of its altitude, will allow the launcher to benefit and the upper stage to benefit of the gravity effect and to increase its velocity until it reaches a thermal threshold. It's about to reach it, or even already reached it now, and it will go up. And now it will go up and up to the separation of the Webb telescope. It will separate the Webb telescope on a highly elliptic orbit, but still around the Earth. The telescope will be released, inserted on an orbit around the Earth, with an apogee, a very high apogee above 1 million kilometers.
Trajectory nominal as reported by Jean-Luc Voyer. You see him in that view, 185 kilometers in altitude, some 4,500 kilometers downrange from the launch site here in Kourou, moving at more than 8 kilometers per second. Right on the plot, right on the trajectory, everything looking great. We are about 9 minutes away from the completion of upper stage ignition. It's shut down, and then about a 2.5 minute coast phase before Webb will separate. Observatory separation will be called out. You'll be hearing those calls and the initial calls from Carl Starr, the mission operations manager at the Space Telescope Science Institute at Johns Hopkins, through solar array deploy and the declaration of a power positive spacecraft. James Webb, of course, will be traveling well beyond the moon to a distance of about 1 million miles away from Earth, settling into a highly elliptical halo-like orbit to begin its astronomical observations. And again, as we mentioned earlier, at the time of observatory separation, Webb will be at an altitude of approximately 864 miles, statute miles, traveling some 21,000 miles an hour.
That's 1,000, 2,000 miles an hour, very, very fast speed.
We're about 8 minutes away from upper stage shutdown. The stage has performed as planned. No issues reported. The launch occurring at 12:20 Greenwich Mean Time, 9:20 Kourou time, 7:20 a.m. Eastern Time on this Christmas Day.
Very smooth. The velocity you just mentioned is very important, Rob. The velocity you just mentioned at separation of the telescope is very important. It will be slightly below, okay, I give it in kilometers per second, but it will be slightly below 10 kilometers per second, because it's important that the satellite, the telescope, is not inserted on an escape orbit. It will be placed on a terrestrial orbit so that there will be time for the layout, for the early phase operations and the commissioning of the telescope. And that will be, in fact, the upper stage that will leave this orbit and goes toward an escape or liberation orbit.
And of course, even though we're still in powered flight, the trajectory, the acceleration, the speed at which James Webb is going towards its preliminary orbit, all modeled in advance and carefully choreographed to maintain as quiescent an atmosphere and environment around the telescope for its ultimate separation from the upper stage of the Ariane 5 rocket, which is about 6.5 minutes from now. Eighteen and a half minutes into the flight. It's very quiet now here in the control center here in Kourou.
It's a very, very important time, right?
NASA officials, European Space Agency officials, Arianespace officials, all watching telemetry very carefully. And as the upper stage continues to burn nominally and sheds fuel, the acceleration uphill for the James Webb Space Telescope continues to increase as we approach the 20-minute mark into the flight.
As you can see,
Again,
it's now
upper stage
nearly-
cutoff is scheduled at the 24-minute, 51-second mark into the flight, about 5.5 minutes from now.
It's around 9 kilometers per second. It's a very,
After
very
the
big
cutoff of
increase.
this main
Let's
engine,
look at the progress.
as you said, Rob, we will have a short ballistic phase, a short coasting phase that will, when the upper stage will rely fully on its what we call the attitude and roll control system, and it will adjust its attitude so that during this small ballistic phase, all the requirements from the telescope are fully met, and that at the separation, when there will be the separation, the conditions will be very smooth and as requested for the telescope.
Le pilotage est
beginning
calme,
of
la
life.
propulsion est nominale.
Today's countdown was as flawless as you can imagine. The weather was perfect all the way through the early morning hours, through the fueling process of the vehicle. The weather's been a bit dicey here in Kourou over the past few days, but everything fell together on this Christmas day to send a new present to the world's astronomer. 20 minutes, 40 seconds into the flight.
Trajectoire normale, tous les paramètres à bord sont normaux.
All parameters nominal as reported by Jean-Luc Voyer, the range operations manager. 4 minutes of powered flight remaining.
The telemetry of the launch vehicle is acquired for the time being by the Libreville tracking station on the western coast of
Trajectoire est
Africa.
normale.
Flight control is nominal. The trajectory is fully normal, fully as expected, as you can see on the plot with the yellow plot over the green one. That is the expected one.
22 minutes into the flight. Less than 3 minutes of powered flight
Pilotage
remaining.
est calme.
3 minutes left,
Smooth
and
flight
then we're
control.
going to get something different. So around 7,000, almost 8,000 kilometers.
And again, as we've mentioned
Les
before,
paramètres à bord sont normaux.
From the Kourou space
everything
station.
nominal reported by the range operations manager. As we've mentioned before,
Acquisition de la
this is a
télévision par la
long
station de
ride
Malindi
uphill
au
for
Kenya.
the James Webb Space Telescope to put it at the proper position in the sky so that it can escape from the Earth, basically head beyond the moon towards its final orbit for its commissioning activities that will be the dominant feature of all of the operations from the Space Telescope Science Institute over the course of the next several weeks.
And the launch operations manager announced the acquisition by Malindi, by the Malindi station, as expected, for the end of the flight and the last part of the upper stage flight and the separation of the telescope.
James Webb is about 4 minutes away from separating from the upper stage. And again, at that point, it will be on its own. And again, those milestones that we discussed a bit earlier in the broadcast will begin to be followed carefully by the telescope controllers at the Mission Operations Center, the MOC as it's called, at the Space Telescope Science Institute
La
in
propulsion est nominale.
Baltimore. One minute of powered flight remaining.
Only around a minute, and then we are going to get
The upper
The
stage
extinction
continues to
of-
function perfectly. It's been a smooth ride for the James Webb Space Telescope.
Gets around by 20.
Trajectoire est nominale.
That upper stage was loaded pre-flight this morning with 15 tons of propellant for this long 16-minute burn. Now about 30 seconds away from upper stage cutoff. And we're standing by for upper stage shutdown and the cutoff of the upper stage engine.
Done. With complete separation.
Extinction ESC.
So it's over the continent of Africa.
Les paramètres à bord sont normaux.
Going.
The extinction of the shutdown,
Towards
the
higher
cutoff of the engine
altitude.
was confirmed exactly as expected,
Kilometers per second.
with the exactly expected altitude and speed and velocity. So now we have entered the coasting phase, the ballistic phase, that will last for a little more than 2 minutes.
So we have reached around 1,000.
And the telescope controllers in Baltimore confirming that all of the function parameters for the James Webb Space Telescope have been loaded on board the telescope. We are expecting Webb separation at the 27-minute, 7-second mark here into the flight. Just over a minute from now, Springs will gently push Webb away from the upper stage of the Ariane 5. As it moves further and further away from the upper stage, there'll be what we refer to as a collision avoidance maneuver.
Yes, Rob, exactly. The Springs already will give some distancing, of course, between the two objects, between the telescope and the upper stage. And then the upper stage will leave the trajectory of the telescope and makes a special maneuver to pass the telescope and heads towards a liberation orbit and leaves the telescope on its orbit without any risk of collision and without any risk of pollution towards the telescope.
And we're about 17 seconds away from Webb separation.
So in a few seconds, they're going to see the upper stage, the second stage, getting detached from the space telescope. And this time, there is no connector between, it's done. So.
Séparation Webb Space Telescope. Go Webb!
As you can see, the dimension is very happy. And
we do have confirmation of observatory separation. The James Webb Space Telescope emits applause here in the Mission Control Center.
Thank you.
Now taking its first steps in pursuit of cosmological discovery.
Let's see.
It was a perfect ride to orbit. And all of the separation sequence events are running in good fashion according to the telescope controllers.
As you can see, that's the, now you get the signal, right?
And there is the view from the upper stage camera on the Ariane 5 looking at the James Webb Space Telescope as it moves gently away from its launch vehicle.
And this means that the telescope is literally away from the stage. And the camera which you're seeing is, I'm definitely sure, it's the second stage cam, which is this, the stage.
Ironically enough, as we marvel on this view from the upper stage camera, this will be humanity's last view of the James Webb Space Telescope as it moves to its workplace about 1 million miles away from Earth.
Yes, you're right, Rob.
Last close-up image.
Fantastic pictures.
Space.
Now we'll be hearing shortly from the mission operations manager at the Space Telescope Science Institute, Carl Starr, who will be calling out the procedures that will lead to the deployment of Webb's solar array.
As you can see,
And down in the fishbowl where there is jubilation, let's go to Raphael Chevrier of Ariane Spas.
so as you can see the solar array is being
And before we do
extended.
that, Raphael, a bit earlier than planned, but there is the solar array having been deployed. James Webb now has its array out as we stand by for a confirmation that it is power positive.
Yes. Power positive means, you can generate
Okay, Rob.
electricity from the solar array. So this means literally we don't need any fuel technically for all the instruments to work. We do not need other instruments for help, right? So I guess we can stop sharing because now it's done.
And there it is. There's your critical call. James Webb not only has legs, but it has power as it begins its journey and the commissioning activities to follow. And with that, let's go down to the floor in the fishbowl and Raphael Chevrier of Ariane Spas.
Okay.
This is it. We have witnessed and the confirmation that Ariane 5 have safely delivered Webb into space. The upper stage is now being placed on a safe escape orbit around the Sun. But honestly, I've got to tell you.
Yeah. So that is a very, very interesting stream. That was a very interesting launch, a very successful launch. Just a second. Let's just have it. Okay, fine. So I have one thing which I had to show you, and that was the website. I had still a lot more to explain from the website, and it is thank you to the Everyday Astronaut, which has helped us do this. They also have their live stream going on YouTube. So the link in the description below, in the live box. Just a second. So he's currently live on YouTube himself, and here it is, link. The link is in the description. You can see that as you can see here, link here down, so you can see that. So what I wanted to show is literally this. Fine. Okay, so as we have gone here, you see live. I've already sent the link in the description. Okay, so what is the Earth Sun Lagrange point 2, right? Let's just go down here. There is a lot of right. Just a second. Yeah. So before I go here, yeah, here's the orbit. So as you can see, L2 is here. It's going to be orbiting in a halo that is like a round, like an ellipse, right? So these are 2 points, but actually there are 5 points where the balance is perfect between the Earth and the Sun. So it'll be operating at the second Lagrange point of the Earth-Sun system. It'll be orbiting in a halo orbit. The Lagrange points are points in space where the gravity of 2 large objects like the Sun and the Earth balances out the centripetal force needed for a spacecraft, such as the JWST, to move with them. This means that very little fuel is needed to keep a spacecraft in desired orbit. So there are 5 points. L2 is around 1.5 million kilometers away from Earth. And it's behind the Earth, as you can see here. It's much, much more farther away than Earth, than the Sun and the Moon. So initially, you can see, I'm pretty sure you will be able to say that this is the ISS, this is the Hubble, and this huge distance is the James Webb. And we have got many other astronomical missions there, like Planck, Herschel, WMAP, which are other missions focused at this point. The observatories, the observatory's halo orbit has a radius about 800 kilometers. I'm sorry, 800,000 kilometers, and when which the spacecraft will take around half a year to complete. Half a year, that's around 150 um, days to complete. And as you can see, approximately, it's not exactly correct, but this 1.5 million kilometers is exact. Fine. And why is it infrared? That's quite a good question given here. Now, what is the thing is, due to some laws in physics, as the point, right, um, the as the light from the point starts to move towards our satellite, it loses on some of the energy, and it becomes with a more relaxed wavelength. As you do in a wave, you have something which is like a gamma ray, and it has a very compressed and a very low wavelength. There is nothing but the difference between two um, troughs, and what, I don't remember. But then yes, right. So you have two the distance between two consecutive points, and higher it is, uh, the lower energy it has, and lower it is, the more energy it has, the more compressed it is. So as the distance is passing out, you're going to get weaker this. And if I go into the um, electromagnetic, right? So this is the electromagnetic spectrum. Just 1 second. Um, yeah. So this is the electromagnetic. As you can see, the wavelength is reducing, and is increasing, and it starts from here, starts to become here, right? Radio waves is the final. Gamma rays, from the point it starts to become more smaller. We've got ultraviolet radiation, we've got visible light. Now this is the point where Hubble and this brand new space telescope can be differentiated. Is because the visible light is what Hubble looks at very high precision. Not to forget to mention that, but the James Webb, this telescope, can catch this to probably forever, because it's very simple to catch the others. But infrared light, the universe appears completely different, because you get to see more things in electromagnetic, which are more like radio wave, infrared, than visible light. Visible light only to us humans, as in from the eye, but then there's a lot more, and that's what the space telescope really is going to be famous for, right? So I'll just continue with the sharing. Just continue. Yeah. So I wanted to look at this. Fine. This is the differences. You can see more. As you can see this, like literally, this is just visible light. The one on the camera, which is more on the colored side, you can see only a bit. And through this gas, through this nebula, you cannot see anything. But if you go through infrared, you can see a lot of things. You can see a lot. This is the Carina nebula, and this is through the Hubble Space Telescope. Although IR is in a very short, in a very long wavelength. I guess short wavelength is a long wavelength is quite difficult to catch. So the short wavelength, you can see many more stars when compared to this. Right? So ECA, we have already checked it. boosters we are using. We are not going into this because most of the viewers don't have that high information about this. So let's just go up to one important thing which I wanted to do, and this is the deployment timeline. A very, very explained sequence. Right? So as you can see, we have fairing separation. We have seen that separation from the launch vehicle. We have seen that solar array. This was 33 minutes, but then he also in the stream said it is quite earlier than expected because it was going to be 3 minutes, but it was only around a few seconds. Then we have got gimbaled and in a deployment, there's a sunshine, and over these 2-3 weeks, we're going to get a perfect um, James Webb telescope. Everything is going to be unfurled by that time. And as you can see, this is the L2 point. Let me just move on. The ISIM, the primary and the secondary mirror. It's a very, very big difference between this and this, and the primary mirror of both the James Webb and the Hubble Space Telescope. As I said, the optical telescope element. This is the sun shield, and it's going to be in very, very close to absolute zero, right? So if it is hotter than this, then the telescope's own infrared radiation will be expelled out, and that will cause problems in the, and as you can see here, 5 different layers. Now the spacecraft bus is the brain of the telescope. And who was James Webb? This is a very important thing of the launch. So who was James Webb? James Webb was the second administrator of NASA, and he was known for heading the Apollo mission. When there was the Apollo, the Cold War going on, he was the administrator of NASA, and he was just a very very important person in our advent to outer space, because if it wasn't for him, if it wasn't for the proper administration of NASA, probably the Soviets would have been the first to go to the moon. And the famous lines, this is a small step for man, a giant leap for mankind, may not happen. And that's why this is a very, very big thing, gigantic importance. Now, what are the primary goals? I've already checked that. What does this all mean? We have already done. And as you can see, right, here the payload mass is around approximately 6,500 kilograms. This is the mass of the James Webb Space Telescope. Where is the spacecraft going to this point? Recovering? No way, this can't be done. First stage will crash. Again, cannot be recovered. Attempting to fairing, recovering, because this is not possible with the Ariane. When you are recovering your fairings, probably you should actually give a bit of thickness to those fairings, because you have to detach the what do you call them, um, the parachutes. So because you need the parachutes to be installed within it, the thickness increases, and probably the widthness of the allowed payload on this vehicle will be changing at all times. Thank you, Arnav. I guess Arnav is here. Thank you for supporting our channel. So and watching the stream. This is a really good one, and hopefully I've liked this one. Just a few minutes, and these pairings are new. How is the weather looking to be decided? It was a good one. It was a good one. It was around 27 degrees Celsius at the launch, and 138th orbital launch attempt of 2021. I guess There are only around 2-3 launches left, but then literally they're going to be doing it. As you can see, latest pre-launch preview. This is from the Soyuz and OneWeb. This is a satellite company. We've got 289th Ariane space mission in its history, the 289th and 112th Ariane 5 mission. So this is the entire thing. I would like to thank again Everyday Astronaut. Link is in the live chat. If you're there, then do consider watching and definitely do consider subscribing to our channel. Fine. So if you are on Discord and you want to look for my server, I already have one. Link is already sent. It was way before the launch, around 2 hours. But yes, the link is in the description. It's only going to work for 7 days. It's in the live chat, and do subscribe to our channel. I'm aiming for one more launch. It's not fixed, but maybe I'm looking at one more launch. Then yes, we're going to be doing another one. Not fixed. I really want to do one, but let's move on. Let's just move on with the section 3 of this launch, this live stream, and that is the Q&A session. If you have any questions, post them in the description box, and I will be aiming to answer them. Hopefully they'll be very tough, but yes, I would be aiming to answer them. Okay, so let's just see at the comment section. Whatever question you have, I'll be ready to answer them. Um, and yes. Um, yeah, I've got a few personal questions. I've got a few facts for the James Webb Space Telescope. So literally, the James Webb Telescope is literally the largest telescope in the history of space telescope. The primary mirror, as I said, is made of gold, but just 1,000 atoms thick. That is just as much weight it is in a golf ball. And if you have carried one, it'll be quite heavy. The JWST cannot be serviceable. That's one important point, and that is because you know it is at a point which is too far for a spacecraft to reach. 1 million kilometers isn't less, I would say, and JWST can see clearly a coin. You can see the 1 rupee coin that we have around 38 kilometers away, clearly 38 kilometers away from it, due to the high-tech cameras. And the cameras on board are so dated that they can clearly see water on a planet which is not Earth, I would say, probably, but other planets in the outer space. It can see that. JWST will see the first light created by the Big Bang in infrared radiation. Pretty sure it is going to be shortwave infrared, or sorry, long wave. Then it'll be unfolding on its way to its new home as it is. And there would be no problem. There's not going to be no drag because it's space, it's vacuum, so you're not going to get any problem. Side is always facing the sun, would be as hot as the Death Valley. Just a second. Yes. So the side of the telescope, which is going to be looking at the sun, just a second again. Right. So I was telling about this, right? So let's just do it this way. So the side which is going to be seeing the sun, okay, the side which is going to be seeing the sun will be as hot as Death Valley. If you know a bit of the geography, then you will know that this side will be very, very hot. Um, in Death Valley, it'll be very, very hot, and that much hotness, it'll be much, much times more hotter here and here, which is going to be always looking away from the sun. Okay, this part will be near uh, absolute zero, which is around minus 273 point something degrees Celsius. Minus 273 degrees Celsius. We can't even, here in our city, we can't even bear around 10 and minus 273. Oh my God, that's the lowest temperature ever recorded. And that's why, as a common sense, if I would say, these instruments would be working at near um, absolute zero. Fine. And, then we've got another JWST will be launching very far. We have already seen that launch. It is very, very far away from India. And this one's very, very far away. It's already in space, so that's quite nice. Okay, hello and good night. Okay, goodbye. This is the final part of the live stream. I'm very thankful to everyone